As you know, in the project, each student will be given a set of flight conditions and their engine geometry. In this video, I'll go through how you get your conditions and how you use them in submitting your answers for the assignment. In step 1 of the project, you'll be given your flight conditions and geometry. At the bottom of the box for step 1, you'll see a Show Answer button. When you click on this button, you'll get the information required for your design. It will look something like this. At the very top of this information is an 11-digit code. This code is very important. It contains all the information about your flight condition and geometry that you'll need to be able to check that your answers are correct. Make careful note of your code. If you lose it, you can always come back to step 1 and click on the Show Answer button again to get your code. As I'll explain at the end of this video, you have to enter this code into the box at step 2 and ensure that it's in the box whenever you check your answer for a step in the project. Let's look at the data that you'll be given. Immediately below your 11-digit code are your flight conditions. Zooming in on those, we see that this includes your flight mark number M1, the static pressure of the air through which your engine is flying, P1, and the static temperature of the air through which you are flying, T1. Your altitude will also be displayed, but this is just for your reference. Use the specified P1 and T1 in your calculations. The next information is about your engine's geometry. All engines are two-dimensional, and the width of your engine W is given at the bottom of this section of data. The width is the distance out of the screen. At the top of this section is your engine's capture height, HC. For all engines, we have set both W and HC to be 1.0 metres. So the capture area of all the engines is 1 metre by 1 metre, so 1 metre squared. Next is the deflection angle of the first surface of the inlet, θ1. The vertical height of this surface, h1, is given next. Then the additional deflection angle of the second surface, θ2, is given. Note that θ2 is measured relative to the angle of the first deflection surface. The vertical height of this surface is h2. The height of the combustor is h3. And the last piece of geometry is the height at the exit of the thrust nozzle, he. This completely specifies the geometry of your engine that you need to calculate the engine's performance under the assumptions that we're making. There are no length scales for the combustor and the thrust nozzle. We don't need those with our assumptions of Rayleigh flow in the combustor, quasi-one-dimensional isentropic flow in the nozzle, and no viscous forces. The last piece of information is about how much fuel your engine is to use. This is specified in terms of the equivalence ratio of the fueling, which is phi. As you will recall from section 4, this indicates what fraction of the stoichiometric mass flow rate of fuel we are using. Next, I want to identify the locations in your engine where you'll be required to calculate flow conditions. We'll number these from 1 to 6. State 1 is the undisturbed oncoming flow condition. State 2 is the condition of the air behind the first shock wave in the inlet. State 3 is behind the second oblique shock. And State 4 is behind the third inlet shock. State 4 is therefore the condition of the air as it enters into the combustor. The condition of the air after the heat of combustion has been added is going to be referred to as State 5. This is the condition of the air that enters into the thrust nozzle. Finally, the condition of the air as it exits the nozzle is going to be State 6. I said earlier in the video, you will have to enter your personal 11-digit code into a box at step 2. You need to ensure that this number is in the box whenever you check your answer for a step in the project. The box at step 2 will look something like this. You need to enter your 11-digit code here. Important. If you leave the page and enter it again, you will need to re-enter your code into the box at step 2. So always ensure that the code is there before you check your answers. I think you'll get a strange looking error message from the system if you don't have your code entered. So if you get that, just go back to step 2 and enter your code again. In the next video, I'll give you a brief summary of what you need to do to calculate your engine's specific impulse.